So today we'll be looking at cube root of numbers. Last time we met, we learned how to cube numbers. Today we're going to talk about the inverse operation of cubing, which is the cube root. I would start by showing the students my three squares from the bead cabinet. And if I were to stack my three squares one on top of the other, I make a cube of three. A cube of three. So a cube of three is a square of three taken three times. Taken three times. So a cube of three is 3 by 3 taken three times, or 3 by 3 by 3. We know that the value of a 3 cube is 3 times 3 times 3. So the value would be 3 cubed is equal to 3 times 3 times 3. It's also equal to 3 squared times 3, which equals to 9, times 3, which equals to 27. So my 3 cube is 27. We could do the same analysis with the students with my 2 squares. So I have 1 2 square and a second 2 square. When I stack them, I get a 2 cube. A 2 cube is a 2 by 2 taken 2 times, or a 2 by 2 by 2. So I could write 2 cubed is equal to 2 times 2 times 2, which is equal to 2 squared times 2, which is equal to 4 times 2, which is equal to 8. I would have the students do this kind of analysis for all of the cubes in the bead cabinet and come up with a table of numbers and their cubes in the manner which I show here. So if we go back to the 3 cube, we know that 3 cubed has a value of 27. Just like before when we looked at the square root, we can look at the cube root and say the cube root of 27 is equal to 3. Okay, and just like in the square root, we read the answer along one of the edges. So the cube root of 27 is equal to 3. And now I could introduce the notation. We again use the radical sign, just like we did before, but this time we're looking at the cube root. So I will write a 3 right above the little line there, and I would write the cube root of 27 is equal to 3. Likewise, I could write the cube root of 8 is equal to 2. So now we're going to find the cube root of a number using the Montessori cubing materials. We're going to start with the cube root of 79,507. And just like we do when we do the square root, we are going to put a tick mark counting by 3s instead of 2s this time, starting from the right. And these two groupings tell us that our answer will be in the tens and the units. So we're going to look at our chart here of cubed numbers. And if we look at 79, we're going to try to find the largest cube that we can make with 79. And if we look at the cube root, the cube of 5, which is 125, and the cube of 4, which is 64, we see that the cube of 4 is the largest cube that we can make. So we are going to write a 4 here for the root, and we are going to place 64 underneath the 79. And I'm going to actually just place that, let me put it right there so you can see it. That is our 4 cube where we're starting. If we take the difference between 79 and 64, we are left with 15. And now we are ready to bring down the next digit, which is 5. So if we look at our chart, if you remember when we did our cubing and moving from one cube to the next cube, you'll remember that we would always add layers 3 times. We would add layers in one dimension, layers in the other dimension, and layers in the third dimension. So whenever we're moving from one cube to a larger cube, that's what we do. So here we have 3n squared, okay, because we're going to be building our cube with squares, and we're going to be doing it on 3 dimensions. And in this case, if we look at 3n squared for 4, which is what we need, we get 48. All right, so we need to figure out how many times 48 will go into 155 so that we can estimate the number of layers that we're going to need to build up. So if we do this division, we get a value of 3. Of course, it's not exact, but that's the closest whole digit that we can get to. So that means that I'm going to build 3 layers. So here's my first layer of 3 4 squared. Here is my second layer of 3 4 squared. And then I have my final layer this way of 3 4 squared. So now I'm going to calculate 48 times 3, which is 144. So that is how much I have used of my 79,507. That's how much I have used to build my layers. All right, so I'm going to take 144, subtract it from 155. And that gives me 11. I'm now ready to bring down the 0. Okay, so if I look at my model here, I can see that I'm going to have to build, and remember I'm trying to get a cube, going to have to build with 3 squares, yeah? Because I have 1 2 3, 1 2 3, and 1 2 3. So I am going to start building. I have my 3 squares right here, which I'm going to put in this dimension. And then I have my 3 squares right here that I'm going to put, oops, sorry, that I'm going to put in this dimension right here. And then I have my final 3 squares, which I'm going to put right here. And I have now built up my cube, except for this one area here. So let's figure out how many, what value we've used up from the 79,507 with these layers. Well, we did 3 squared 4 times, right? 3 squared 4 times, and we did it for 3 dimensions. That equals to 108. I'm now going to subtract 108 from 110. That leaves me with 2, and I'm going to bring down the 7. So if I look at my model again, I have a space here that needs to be built up, and it happens to be 3 cubed. That makes my larger cube. So in this case, 3 cubed, of course, equals 27. So it looks like I have no remainder. And now I can read my cube root off my model, and I can see that it's 43. 43. And there is my cube root of 79,507.